In this video, we're going to review something called sigma notation. This is something that you were supposed to have learned about in a previous class, pre-calculus, college algebra, something like that. But it's possible you have never seen it before, or if you have, you didn't really remember it because you don't use it that often. But it's going to be pretty important in the next section here. So first off, this is the Greek letter capital sigma. And what it means in mathematics is it means you're going to add stuff up. So anytime you see sigma, it means you're adding up numbers. That's all. That's all it means. There's no other hidden meaning to it. With that said, there are some specific things we will put on it to tell us what it is that we're actually adding. So if you look at this, it's a typical example of what you might see using this notation. First off, the bottom of it, this is going to tell you what your variable is. So in this case, we're using k, and we will often use k in this class. However, you don't actually need to use k. You could use whatever letter you want for your variable. Doesn't really matter. And once it does, we know that k is our variable. We also know the starting value of k. So in this case, the starting value is going to be 1, which is a pretty common starting value for these sigma problems, but definitely not the only starting value you'll have. On top here, we're going to get the last value of the variable. So in this case here, the last value we're going to have is 5. And then the part on the right of the symbol, this is going to be what you are adding. So in this case here, this is going to be, we're adding up k squared. So let's kind of start over now and actually see what we're going to do here. So my formula is k squared. That's what I'm going to plug k in. So I start by plugging in the first k, which is 1, and I would get 1 squared. Then I'm going to keep plugging in the next value of k until I get to the final value. So after 1 we get 2, we're going to plug that in and get 2 squared. After 2 we get 3, we're going to plug that in and get 3 squared. After 3 we get 4, we're going to plug that in and get 4 squared. After 4 we get 5, we're going to plug in 5 and get 5 squared. And then because that's our last value, that's where we stop. And then the last thing we need is that it's sigma, so therefore we're adding these things together. And so then we literally are just going to add up these numbers here. 1 plus 4 plus 9 plus 16 plus 25. And we get 55 here. So that means that this symbol, it just means the number 55. That's just a different way of writing the number 55 using this notation. Okay, so now that we have that, let's look at another example here with a different formula that we're going to add. And so this time it says you start with the value k equal to 3, so I'd have 3 factorial plus 3 plus 1. Then we plug in 4 factorial plus 4 plus 1. And then we're going to add up those numbers. Well, 3 factorial is 6. And then 4 factorial is 24. And then 10 plus 29. And this gives me a value of 39. Okay, so what we're trying to do is we're just trying to see how we can use this sigma notation and figure out the value of it. With that said, there are a few special cases where you can save yourself the effort of actually plugging in the numbers and adding them up. The first special case is what happens if you're just adding a constant or adding a number over and over and over again. For example, if I were to add the number 5 7 times, 2, 3, 4, 5, 6, 7, sure, you could actually add up 5 plus 5 plus 5 7 times. Or you could just know that it's 35 because that's 7 times 5. So this is just saying take the number you're adding and multiply it by how many of them you added, and that gets you your c times n. Okay? The next one is, what happens if you are adding up the numbers in order, 1 plus 2 plus 3, up to, say, 10, and you want to find the answer? Well, this formula here gives you the answer. It's going to be 10 times 10 plus 1 over 2. So the answer is going to be 55. So it's just a shortcut for when you're adding up increasing numbers up to a fixed point, which we're going to call n as our final value there. And there's also something similar for if you're adding up the squares of numbers. For example, we did this already, we got 55, but we could have seen that we're adding from 1 to 5 here, so I could plug in 5, 5 plus 1, 2 times 5 plus 1 over 6, and without having to actually write them all out and add them all up, we get the answer 55 there. So that's a perfectly good option, and there are times when you really want to have these formulas, specifically when you want to do limits involving these problems, but at this point in time, they're just kind of shortcuts to make things work out nicer. Let's show you how we might use that with a specific big number here. So we're trying to add up numbers from 1 to 50 of 3k plus 2. If you want to do that by hand, it would be a gigantic pain, right? You write out 50 different numbers and add them up. You don't want to do that. So instead, what we're going to use this formula here, but what I'm going to do is I'm going to think about it. When I'm adding up 3 factorial and 3 and 1 and so on like this, I could have, because I'm adding, I could have just added up all the factorial parts first, and then all the parts that were just k, and then the 1 separately. So what you can do on these summations here, and you can even factor out 3's, you can just break it up into multiple summations where you split apart each of the different parts of their formula, and then that way each one you can work out. So for this first one, we know by rule 2 it's going to be 50 times 51 over 2, and the second one by rule 1 is going to be 2 times 50, and then we just put that in our calculator really quickly here. And we get the total answer of 3,925, and we did that without having to write down 50 numbers and add them up. So these formulas can be very, very useful when you're adding up a lot of different numbers. And now, as I said, we actually like doing this when we have a limit here. And notice that this limit is going to be the limit as n goes to infinity of this. Now what I'm going to do is I'm going to break up this limit, or the summation here, into two parts. The first part, 3k over n, and then the second part, 2. Just like I broke it up in the previous example. And then I'm going to factor out constants. Now, you might have a problem with factoring out n's, but since our summation is talking about k, then that means n really is a constant there. And then we can go ahead and use rule 1 and rule 2 again. And we'd have 3n, n plus 1 over n squared plus 2n over n. Do a little bit of algebra here. And if we take this limit, we're going to get 3 plus 2, which is 5. I do want to point out that previously we would only have using these formulas to save some time here, but when we're doing limits and the top is some unknown variable n, we can't do it any other way than using these formulas because we don't have a fixed number. We can't write out 10 of them or 100 of them because we have n of them. And so this is the time when you really do need to have those formulas down.